Hi everyone, my name's Louisa and I'm going to teach you today about how we find the equivalent resistance of resistors in series, and we're going to do that by looking at a couple of exercises. So first, let me just start by going over what we talked about before in the lectures, which is that when you have two resistors, R1 and R2, that are in series, and you want to find the total resistance when traveling through both resistors, we're going to do something called finding the equivalent resistance. R equivalent. Now there's two different ways that you calculate this depending on whether they're in series, as they are here, or in parallel. Parallel will be covered in a separate video. Today we're just going to talk about how to do this when they're in series. So it's actually very simple. When you have R1 and R2, for two resistors that are in series with one another, R equivalent, or the total resistance, is simply R1 plus R2 equals R equivalent. So, just to clarify, that means that we can take a circuit that has two resistors and draw a circuit that has one resistor, and we simply add those two resistances together, and this is actually the same exact circuit. The total resistance is the same, it behaves the same way. So that's the lesson. Now we're just going to take a look at some basic problems. They should be simple, but I'll try and explain why this is true as we're doing it so it's a little bit more useful. So here I've just got a simple circuit with two resistors in series, one with a resistance of 3 ohms and one with a resistance of 5 ohms. So like we said, to find the equivalent resistance, we're just going to add them together. We get 3 plus 5 equals 8 ohms. And so we can redraw the circuit with only one resistor with a resistance of 8 ohms. Now you might be wondering why this is true, and it actually makes perfect sense, because when you think about it, the electrons start here at the negative terminal, and they travel along, and they travel through this resistor, and then they also have to travel through this resistor because they're in series. So the fact that they're in series means that any electron traveling through one also has to travel through the other. The same sort of motion of electricity will occur through them both. And that means that any resistance that one puts up to the movement of electrons is going to just be added to the resistance of the other. It has to go through both. Therefore, the total resistance that it faces is the sum. Now let's just take one more look at an example problem. Again, these should be very simple, but let's just show you that this continues to be true even if we have many resistors in series. So here again we just have a simple circuit. It's just a single loop with 4 resistors in series, 10, 8, 1, and 6 ohms. So the total resistance, we're just going to add them all up. We've got 10 plus 8 plus 6 plus 1, and that just gives us 25. Oops, I almost wrote 24. So it really is that simple, but this, remember, is only when they're in series. Now in the next video I'm going to show you how this works when they're in parallel. The math is a little bit more difficult and the concept is a little bit more difficult, but if you really sort of try and picture it in your head, you should be able to understand.